Hi, I'm Bob Tabor with www.learnvisualstudio.net. I really don't want to rush through this. I mean, there were some key takeaways from that previous lesson that are important enough to elaborate on as we're getting started here. So let's take a few moments and chat about what we just did in the previous lesson. First of all, I hope you realize that you're going to be able to leverage your existing knowledge of creating user interfaces and doing so in Visual Studio and apply that towards creating Universal Windows Platform apps. Did you notice how similar it was to creating WPF and ASP.NET Web Form apps? That was no accident. It's a very similar experience and a very similar workflow. And as a result, it's just as fun and it's just as easy. And, certainly there's a lot to learn here, but it's really nothing to be intimidated about. So, as we pointed out, we have a couple of different options for laying out our application, at least here at the very beginning. We were able to make changes to the user interface in the most visual of ways by dragging and dropping controls from the toolbox onto the design surface, and we could even resize things and move them around. And we also can make changes in the properties window to modify the various attributes of the controls that we see on screen. However, I think you're going to find that, just like HTML, a visual designer won't give you the level of control that you're really going to want over the various properties and how they relate to each other. So there's really no way around learning the actual XAML syntax itself, and we'll begin learning about that in earnest in the next lesson. Furthermore, just like ASP.NET Web Forms and WPF applications that we created, every screen, or rather every page, has a code behind file that's associated with it, where we can write event handler code in C# that perform operations whenever the user interacts with our application in a given way. So we can also see that there's that same relationship here between, as we noted in the previous lesson, the mainpage.xaml and the mainpage.xaml.cs. In fact, what I want you to notice is here in the mainpage.xaml.cs, you can see that we're in the namespace hello world and we're creating a class called mainpage. Notice that it's a partial class. Now, I'm not sure that we talked about this in that fundamental series in C#, but essentially we can create multiple files and all have them be partial definitions of a single class, stored in different files, whatever the case might be. But as long as that file has the same class name, it's in the same namespace, and it has the keyword partial, we can create many different files to represent a class. Same thing is true here. So notice that this main page derives from an object called page. If we were to hover over it, you can see that this is a class called windows.ui.xaml.controls.page. Now, if you go to the main page.xaml and look here at the very top, notice here that we're working with a page object, and notice that the class name is also hello world namespace main page class. All right, so that's when I said that these were two parts of the same puzzle, two puzzle pieces that go together. What I really meant to say is that these are two different files that represent the same class. One of these files represents the class from a visual perspective, and the other represents it from a behavioral aspect. Okay, and we'll talk about this more a little bit later. And then after we kind of built our whole application and we were able to run it in debug mode, and I didn't demonstrate this at the time, but we can do, and you can see I've already done this once or twice here, you can use breakpoints. You can, for example, if we set this back to local machine and actually run the application, we can then click the button and we'll be in debug mode at that point when we can evaluate different property values, variables, whatever the case might be. We can use all the same little tools that are available to us when building any other style of application. The one thing that I noticed, or that I pointed out, but I didn't really talk about at length, was why there are so many different emulators available here in debug mode. And they're really there to emulate the different screen sizes and resolutions, but then also the different memory constraints for the different hardware, phone hardware that we'll find on the market today. So we could test our application in a low memory environment or test our application in a high memory environment, as well as screen resolutions and sizes as well. And Also, what I didn't talk about whenever we were talking about emulators, and let's just go ahead and launch the emulator. And what I didn't talk about at the time were these actions on the toolbar. Some of them are pretty obvious what they do, you know, like rotation and so on, and just to see how our app looks whenever we rotate our phone around, how to do multi-touch input, and then also just to zoom the application. But then there are also tools that we can access through this double chevron icon at the bottom, and this opens up a whole dialog of additional tools. So for example, if we want to test our application's accelerometer feature, we can record a shaking motion or, you know, some sort of gesture on the phone and then test it and see how our application responds to it if we are actually handling events for those type of gestures. And we can also do the same thing with GPS. And we'll talk about both location services and how to test them using the phone emulator. We'll actually use the phone emulator to tell our application that we're in a different physical location than we really are. It's a great feature. We also, back here on the main page, we also built our app utilizing various XAML controls from the toolbox. We use the button control, and then also, you can't see it right now, but the result text block down there a little bit further. There we go, just a little sliver. And a control has both a visual quality and a behavior, and both of these can be modified by you and I as developers by either changing properties of the control, like we did whenever we modified the XAML or the properties window, or by writing code in response to certain key events at key moments in time in the application's life. Like we did whenever we clicked the little lightning bolt icon and we said, hey, we want to handle a particular event for the button, in this case, the click event. Okay. Now, as obviously the toolbox has dozens of other controls. There are simple controls, input controls like the button and like a text box. There are display controls like the text block that we used. There are input selection controls like drop-down list boxes, or like the date control where we can select dates and times. There are grids that can be used to display data. There are grids and other layout controls that can be used to help us to position controls in our application. You can see that there's actually a grid that came automatically out of the box whenever we started building our user interface. We'll talk about these a little bit more depth a little bit later. But the funny thing is that we'll actually spend a lot more time than you might think learning about layout controls. They're very important to the adaptive story of Universal Windows platform apps. Layout controls allow a single code base to be utilized across many different devices device form factors. And so the Universal Windows Platform API provides this rich collection of visual controls that work across all Windows devices. They allow input via mouse in some cases, or via finger in other cases. But that same API also provides us with thousands of methods across hundreds of classes of namespaces that allow you to do really cool stuff with your application. For example, if you need to access the internet to go retrieve some sort of resource, or if you want to work with a file on the file system, whether it be on a phone or a tablet or a desktop or even the Xbox, or if you want to play a media file like a song or a video. There are methods in the UWP API that make all of those things possible and a lot more, as you're going to learn throughout this lesson, a series of lessons. Additionally, we can harness capabilities available to specific device families using what are called extension SDKs, or rather software development kits. These extension SDKs contain additional classes and methods that allow you to harness features only available on that particular device family. So for example, if I create an application that I intend to run across all Windows 10 devices, great. However, I might decide at some point to add features that only light up, which is secret code for become available, whenever I'm running that app specifically on a phone device. So I can use the mobile extension SDK and gain access to classes and methods that deal with things like accelerometers and GPS and the camera and things like that. So whenever I choose to light up features based on a device family, then I'm writing adaptive code, and you'll hear that term used a lot, especially just the term adaptive. Now, alternatively, I can decide that my app only really makes sense whenever it's running on a specific device family. So here again, I might choose to only allow the app to run on phones because the nature of the application relies so heavily on the Mobile Extension SDK's features. And this would be called a mobile-only app in that case. But the point of this is that we as developers get to decide what device families to target and which ones to exclude. And we'll learn more about adaptive and device-specific considerations throughout the series because it's one of the most important new features available in the Universal Windows platform. Furthermore, not only could our application's core functionality change based on the device family, but also its layout and visual qualities, as well as its navigation. They may need to change based on the screen size. So I can create adaptive triggers that will modify the layout and the scale of items in our application based on the size of the screen. Again, this will be another topic that I'll be demonstrating often throughout this series because it too is one of the most important new features available in the Universal Windows platform. So just backing up a little bit here, whenever I sit down to learn something new, a new technology, a new API, I spend a lot of time just trying to organize things in my mind, making key distinctions, putting things in buckets, I guess you could say. And learning UWP for me was no different. And so here's what I kind of came up with. I categorized all the topics that we really need to understand, you and I as developers. And so then using those categorizations, we'll go through and we'll learn these things, and it'll hopefully be clear how they all relate to each other. So first of all, we're going to need to learn XAML. As I said earlier, we talked about how it's a language that allows us to lay out our forms or our applications. XAML is not specific to the Universal Windows platform. It's been around for about a decade now. But building a Universal Windows platform app really all starts with a fundamental understanding of the XAML language and how to mold it and shape it to do what we want it to do for our application. So learning XAML is number one, and we'll start that in the very next lesson. Then secondly, we're going to need to learn how to use C# to call methods of classes in the Universal Windows Platform API itself. So there is the language, the programming languages, XAML and C#, but then there's also then an API, a library of functionality that Microsoft created that we can tap into and utilize for our applications. And so you call UWP API methods to do meaningful things in your application, like load and save data in a file or access the network, things of that nature. And then third, if you only learned C# from my C# Fundamentals for Absolute Beginner series, and that's all the C# that you know, then there's going to be some new C# features that you're going to need to learn, especially like async, await, and task, these keywords and what they represent. And they're used extensively whenever you're working with the Universal Windows Platform API, and I'll explain why when we get to that point. But you're also going to need to learn about data formats like XML, which is kind of the basis for XAML. Also, we'll cover JSON, which is JavaScript Object Notation, because we're going to call web-based APIs to get current weather from the Open Weather Map API or to get comic book character data from Marvel Comics, and they'll deliver back their data in JSON. So we'll need to learn how to deserialize JSON into a format that we can work with in C#. The fourth thing that we're going to learn about is the tooling that helps us build Universal Windows Platform apps. So we're talking about things like Visual Studio's designers and its wizards and the project template itself. We'll learn about the emulators. So many times you're going to learn about tooling at the same time as you learn about some specific UWP feature, just like we did in the last lesson. So we probably won't spend entire lessons on how to use Blend or how to use some designer surface, right? It'll just kind of come natural to us as we're learning. And then sixth and finally, we're going to have to learn about, at a higher level, as we step back, patterns that we should follow whenever we're building our application. So patterns are guidance. They're good solutions to common problems. There are patterns that help us design our application's user interface so that it looks and it behaves like other Windows 10 applications. Then there are patterns that apply to navigation so that users who have used other Windows 10 applications feel comfortable navigating through the various pages in our application. And then there's also coding patterns, especially when working with data in C# and displaying updates to that data back to the user. So hopefully, we took a few moments here and talked about all these topics at a very high level, and my intent was to orient you in the right direction now. Believe it or not, we've already conquered some of the biggest conceptual hurdles that we'll actually face when learning how to build universal Windows platform apps. It's really not that hard. Now all we need to do is just incrementally add the details. How do I do this? How do I do that? It's not really that hard. It's just take some time to cover the details. But we can work our way through it, and you'll be building your own apps in no time. So we're going to start filling in those details in the very next lesson. We'll see you there. Thanks.